Hi class, I'm your virtual science helper, Mr. Frizzle, and today we're going to learn about motion. So, got a couple of things here. I've got some eggs, I've got a beaker full of red liquid, I've got some tape here, and I've got a ramp here as well. And my friend Mr. Kitty is here to join me. I've also got some money here as well. So, got a lot of things that I'm going to show you guys about motion. First, we're going to start with the eggs. So, one of these eggs is actually a raw egg, still raw, and one of these eggs I've actually boiled. It's a hard-boiled egg. So, we're going to test motion by spinning this. This is a really cool experiment, guys. Check this out. So, we'll start with the hard-boiled egg. Put that in there for safety. So, when you spin the hard-boiled egg, if you spin the hard-boiled egg and stop it, it just stops. But check this out. If I spin the raw egg and then stop it and then go, it spins again. I'll show you again. I'll spin the egg, stop it, and then it continues to spin. I'll do it one more time. Spin the egg, stop, and it continues to spin. So, this happens because the raw egg has something inside of it. It has the yolk, which isn't solidified like the hard-boiled egg. So because the liquid or the yolk inside of the uncooked egg is still in motion, after we stop it, the egg continues to spin because that liquid on the inside is still spinning. And this is due to Newton's first law of motion. An object in motion will stay in motion unless enacted upon an unbalanced force. And since we can't stop the liquid inside of the egg with our finger like we can the shell, that liquid keeps moving, so when we stop putting pressure on it, the egg continues to spin. Isn't that amazing, guys? So, for our next example of motion, I've got this beaker here full of some water with red dye, and I've got this sheet of paper. And what I'm going to do is I'm going to show you, put this here, and I'm going to drag it. See, it's in motion, right? But what do you think will happen if I increase the rate of motion under here? Let's see what happens. Do you see what I did there? When I dragged it the first time, the flash just stayed. But if I increase the rate of motion, then it comes right out. This is the same trick applied when people pull the tablecloth with all the settings still there. Pretty cool, right? So if you increase the rate of motion under a heavy object, the chances of you being able to pull it out is very, very likely, as long as you have yourself a smooth surface and as well as things that are heavy on the table. If there are things that are too light, you may end up flipping them over. And for another test of motion, I've got about, let's see, $1, $2 here in quarters. Quarters are pretty heavy metals, right? And they're all stacked up on top of each other. So I'm going to apply the same thing I did with the beaker, where I'm going to increase the rate of motion. And I can actually count this money, but I don't have to take them off the top. I can take them directly off of the bottom. Check it out. Pretty cool, right, guys? By increasing the rate of motion under the coins, because the coins are stacked up on top of each other, the coins that are on top of each other aren't affected by the motion given to the bottom coin because the rest are too heavy. So just increasing that rate of motion keeps the coins stacked on top of each other, but the others on the bottom moving. Isn't that amazing, guys? Let's clean up this money here. Put that away. All right, so for our last test of motion, guys, I've got my friend Mr. Kitty here, and he's got his fancy car. And what we're gonna do is we're gonna test motion. Remember, Newton's first law of motion is an object will stay in motion unless it comes upon another force. So I've got this ramp here with a brick at the end. We're gonna see what happens when an object in motion stays in motion, but then comes upon a force. First thing we're gonna do is we're gonna take Mr. Kitty down. Inside of his car here. So we'll give him a nice seatbelt. Put one on this side. There we go. And put another on the other side here. All right. Nice and strapped in. Are you ready, Mr. Kitty? Let's go. So, an object will stay in motion unless enacted upon an unbalanced force or another force. Let's see what happens. 3, 2, 1. Now let's see what happens if Mr. Kitty isn't in his safety belt. So, let's remove these safety belt. Are you ready, Mr. Kitty? I'm ready. Second test. 3, 2, 1. We'll do it one more time. Second test. 3, 2, 1. So, as you can see, the car stopped, but because Mr. Kitty wasn't inside of his seatbelt, he went flying in the air and fell down. Because even though the car stopped, because Mr. Kitty wasn't strapped in and not a part of the car himself, he stayed in motion. Same way, he's like the yolk that was inside of the egg. Because Mr. Kitty was inside of the car, but not strapped in. When the car stopped, Mr. Kitty fell over. But when he was strapped in, like the hard-boiled egg, all stuck together when he was strapped in and the car stopped, Mr. Kitty stayed nice and safe. This is important because this is why we always use seatbelts, guys, because if you're ever in a car accident and your car smashes into something, using your seatbelt will make sure that you stop when the car stops and won't keep going. We can go on and on about Newton's laws of motion and how they're so awesome, guys, but we'll get into that in another lesson. Until then, I'm your friendly science helper, Mr. Frizzle. Have a great day, guys. Bye.